Hey guys, today we will study about ionic bonding. In case of any confusion in this topic, do watch my previous video on atomic structure, link in the description below. The stable electronic configuration of a noble gas, the arrangement of electrons in an atom, can be represented using electronic configuration. In what way do noble gases differ from other elements? The noble gases are helium, neon, argon, krypton, etc. These noble gases do not react with other elements to form compounds. They are monatomic elements, means they exist as individual atoms. Atoms of noble gases are unreactive and stable. Atoms of other elements, except the noble gases, are reactive and they combine with other atoms to form compounds. For example, we hydrogen atoms are reactive and can combine with other atoms to form compounds. I'm a neon atom and I belong to the noble gases. Unfortunately, I am monatomic and I cannot react with other elements. Electronic configuration of a noble gas. Helium, He. Neon, Na. Krypton, Kr. Radon, Rn. Helium has two outer, valence electrons. It has a duplet electronic configuration. Atoms of these noble gases have 8 outer electrons. They have an octet electronic configuration. Helium has 2 protons and 2 electrons. It has a duplet electronic configuration because it has 2 outer, valence electrons. Neon has 10 protons and 10 electrons. It has an octet electronic configuration because it has 8 outer, valence electrons. Note, noble gases are unreactive because they have fully filled outer shells, means that they have either a duplet or octet electronic configuration. So now we learn that an atom is stable when it has achieved the electronic configuration of a noble gas, duplet, or octet configuration. How do atoms achieve the electronic configuration of a noble gas? The atoms of elements, except the noble gases, do not have fully filled outer shells. That is why they are reactive. These atoms undergo reactions to achieve the stable electronic configuration of a noble gas. The reactions to achieve a stable electronic configuration take place when atoms lose outer electrons, gain outer electrons, share outer electrons. When atoms lose or gain electrons, they form ions. Forming ions, atoms have equal numbers of protons and electrons. That's why they are electrically neutral. An atom becomes an ion if it loses or gains electrons. In an ion, the numbers of protons and electrons are different. Thus, an ion can carry positive or negative charge. Ions can also be defined as, ions are positively or negatively charged particles. Metals form positively charged ions called cations. Non-metals form negatively charged ions called anions. Formation of positive ions, cations, positive ions, or cations are formed when atoms lose electrons. Atoms of metals generally have a few outer electrons, so they tend to lose electrons to form cations and attain a stable electronic configuration of a noble gas. When an atom loses electrons, it has more protons than electrons and a positive ion or cation is formed. The charge on the cation is related to the number of electrons the atom loses. Examples of cations: positive ions. The nucleus of the sodium atom contains 11 protons and 12 neutrons. Its electronic configuration is 2, 8, 1. Sodium loses 1 electron. It becomes a sodium ion. As sodium has lost its electron, its electronic configuration is 2, 8. Sodium atom has 11 protons and 11 electrons. Its electronic configuration is 2, 8, 1. It loses 1 outer electron to attain an octet configuration and it becomes a sodium ion. Now the sodium ion contains 1 positive charge because it has 11 protons and 10 electrons, hence it has the symbol Na+. Another example of cation. The nucleus of the magnesium atom has 12 protons and 12 neutrons, its electronic configuration is 2, 8, 2. Magnesium loses 2 electrons. It becomes a magnesium ion. As magnesium has lost 2 of its electrons, its electronic configuration is 2, 8. A magnesium atom has 12 protons and 12 electrons, its electronic configuration is 2, 8, 2. It loses 2 outer electrons to attain an octet configuration and it becomes a magnesium ion. Now the magnesium ion contains 2 positive charges because it has 12 protons and 10 electrons, hence it has the symbol Mg2+. Formation of negative ions, anions, negative ions, or anions are formed when atoms gain electrons. Atoms of non-metals generally have more than 4 outer electrons, so they tend to gain electrons to form anions and attain a stable electronic configuration of a noble gas. When an atom gains electrons, it has more electrons than protons and a negative ion or anion is formed. The charge on the anion relates to the number of electrons the atom gains. Examples of anions, negative ions. The nucleus of the chlorine atom has 17 protons and 18 neutrons, its electronic configuration is 2, 8, 7. Chlorine gains 1 electron. It becomes a chloride ion. As chlorine has gained 1 electron, its electronic configuration is 2, 8, 8. A chlorine atom has 17 protons and 17 electrons, its electronic configuration is 2, 8, 7. It gains 1 electron to attain an octet electronic configuration and forms a chloride ion. The chloride ion contains 1 negative charge because it has 1 more electron than protons, hence it has the symbol Cl-. Another example of anion. The nucleus of the oxygen atom has 8 protons and 8 neutrons, its electronic configuration is 2, 6. Oxygen gains 2 electrons. It becomes an oxide ion. As oxygen has gained 2 electrons, its electronic configuration is 2, 8. An oxygen atom has 8 protons and 8 electrons, its electronic configuration is 2, 6. It gains 2 electrons to attain an octet configuration and forms an oxide ion. The oxide ion carries 2 negative charges because it has 2 more electrons than protons, hence it has the symbol O2-. Ionic bond, transferring electrons. When a metal reacts with a non-metal, the metal atoms transfer their outer electrons to the non-metal atoms. Positive ions, cations and negative ions, anions are formed. Ionic bonds are strong electrostatic forces of attraction between positive and negative ions. Compounds that contain ionic bonds are called ionic compounds. For example, sodium reacts with chlorine to form an ionic compound called sodium chloride. Steps involved in the formation of ionic compounds. We can show the formation of an ionic bond by a dot and cross diagram. In a dot and cross diagram, dots represent the electrons of one atom, crosses represent the electrons of another atom. Formation of the ionic compound sodium chloride. Sodium atom has an electronic configuration of 2, 8, 1. The sodium atom loses its outer electron, a sodium cation is formed. Chlorine atom has an electronic configuration of 2, 8, 7. The chlorine atom gains 1 electron from sodium, a chloride anion is formed. Compare these two diagrams with the diagrams on the previous page. Electrostatic attraction holds the sodium and chlorine ions together, sodium chloride is formed. Formation of the ionic compound, magnesium chloride. Magnesium atom has an electronic configuration of 2, 8, 2. Chlorine atoms have an electronic configuration of 2, 8, 7. A magnesium atom loses 2 outer electrons, a magnesium cation is formed. Each chlorine atom gains 1 electron from magnesium atom, chloride anions are formed. Electrostatic attraction holds the magnesium and chloride ions together, magnesium chloride is formed. Do notice the difference between magnesium and chlorine ions and atoms. Chemical formula of ionic compounds. There are some general rules that can help us identify or name compounds. A compound made from 2 elements has a name that ends in IDE, for example, sodium chloride, made from the elements sodium and chlorine, carbon dioxide, made from the elements carbon and oxygen. A compound that contains hydroxide ions, OH-, a negatively charged ion made up of oxygen and hydrogen, is named a hydroxide. For example, potassium hydroxide, contains potassium and hydroxide ions. In comparison to Rule 1 on the previous page, some compounds which contain more than 2 elements also have names ending in IDE. Compounds containing the hydroxide ions are one example. Reminder: polyatomic ions are those which contain 3 or more atoms. A compound that contains a negatively charged polyatomic ion containing oxygen usually has a name ending in ATE. For example, calcium carbonate contains 3 oxygen atoms in 1 carbonate ion. Sodium nitrate contains 3 oxygen atoms in 1 nitrate ion. General rules for writing chemical formulae. For compounds that contain both metallic and non-metallic elements, the symbol of the metallic element is written first. For example, calcium oxide, CaO, sodium chloride, NaCl. The number of atoms is written as a subscript, to the right of the atom symbol. For example, magnesium carbonate, MgCO3, not MgCO3 or MgC3O. The subscripts are the simplest set of whole numbers. For example, calcium oxide, CaO, not Ca2, O2. It is not necessary to write the subscript 1, for example, sodium chloride, NaCl, not Na1Cl1. If the compound contains more than 1 polyatomic ion, the formula of the ion is placed within bracket. For example, copper 2 hydroxide, CuOH2, not CuOH2. Determining the chemical formula of an ionic compound, all the positive charges must equal all the negative charges in an ionic compound. Hence, we can construct the formula of an ionic compound by balancing the charges on the positive ions with those on the negative ions. Let's consider the ionic compound calcium chloride. The ions present are Ca2+ and Cl-. Here, the Ca2+ ion has 2 positive charges but the Cl- ion has only a single negative charge, therefore there must be 2 Cl- ions to balance out the 2 positive charges. Thus, the chemical formula of calcium chloride is CaCl2. Diagram on next page. Note: calcium chloride contains calcium and chlorine. Diagram of how to determine the chemical formula of calcium chloride. Calcium chloride has 2 positive charges of calcium, 1 negative charge of chlorine. There must be 2 Cl- ions to balance out the 2 positive charges. Balancing. Calcium has 2 positive charges, but now chlorine has 2 negative charges, so its chemical formula is CaCl2. To deduce the formula of an ionic compound, we can follow these steps. Write down the ions with their charges, example, Xm plus, Yn minus. Move the values m and n diagonally, but without the charges. The chemical formula is Xn, Ym. What is the chemical formula of aluminium oxide? The ions present are Al3 plus and O2 minus. Move down the values 3 and 2 diagonally, but without the charges. The chemical formula is Al2O3. What is the chemical formula of magnesium oxide? The ions present are Mg2 plus and O2 minus. Since the charges on Mg2 plus and O2 minus cancel out exactly, no subscript is required when writing the chemical formula. When the values 2 and 2 move down diagonally, they cancel out each other. The chemical formula is MgO. What is the chemical formula of ammonium sulfate? The ions present are NH4 with a subscript of 1 and SO4 with a subscript of 2. The subscript of NH4 becomes 2, so we need to place NH4 within brackets. Move down the values 1 and 2 diagonally, but without the charges. The chemical formula is NH4, 2, SO4. Structure and physical properties of ionic compounds. Giant lattice structures of ionic compounds. Ionic compounds form giant lattice structures. Sodium chloride, common salt, is a typical example of an ionic compound. A grain of salt contains sodium and chloride ions. These sodium and chloride ions are arranged in a giant lattice structure. Gray circles are sodium ions, green circles are chloride ions. Giant lattice structure of sodium chloride. A giant lattice structure is a three-dimensional network of ions. The ions are held in place by ionic bonds, and these ions are also packed in a regular and repeating pattern. The giant lattice structure is held together tightly because the oppositely charged ions attract one another strongly. All the green ions are positively charged and all the gray ions are negatively charged, thus they both attract one another strongly to form a strong giant lattice structure. Obtaining the formula of sodium chloride from its lattice structure. To deduce the formula of sodium chloride from its lattice structure, we can determine the ratio of sodium ions to chloride ions in a formula unit. In the lattice structure of sodium chloride, each Na plus ion is surrounded by 6 Cl- ions, each Cl- ion is surrounded by 6 Na plus ions. The overall ratio of Na plus to Cl- ions is 1:1, hence NaCl is the formula of sodium chloride. Physical properties of ionic compounds. Most ionic compounds have high melting and boiling points. In an ionic compound, the forces of attraction between the oppositely charged ions is strong. A large amount of heat energy is needed to overcome these strong attractive forces to melt the ionic compound. Thus many ionic compounds have high melting and boiling points. Due to their high melting and boiling points, most ionic compounds are solids at room temperature and pressure. We say that ionic compounds are non-volatile. Ionic compounds are usually soluble in water and insoluble in organic solvents. Ionic compounds are usually soluble in water. However, some ionic compounds such as silver chloride and barium sulfate are insoluble in water. Ionic compounds are insoluble in organic solvents. Examples of organic solvents are compounds such as oil, petrol and turpentine. Ionic compounds conduct electricity when molten or in aqueous solution, dissolved in water. The circuits which will be shown on the upcoming pages are used to determine whether a substance conducts electricity. Battery. Carbon electrodes. Bulb. Aqueous sodium chloride. When aqueous sodium chloride is used to test substance, the bulb lights up. Molten sodium chloride. When molten sodium chloride is used to test the substance, the bulb lights up. Solid sodium chloride. When solid sodium chloride is used as the test substance, the bulb does not light up. Those three experiments on the previous pages show that, when an ionic compound is molten or dissolved in water, it can conduct electricity. When an ionic compound is in the solid state, it will not conduct electricity. Why do ionic compounds conduct electricity when molten or dissolved in water? There must be free-moving ions or electrons in order to conduct electricity. When an ionic compound is molten or dissolved in water to form an aqueous solution, the cations and anions are free to move and are available to conduct electricity. However, in the solid state, there are no free-moving ions to conduct electricity because the ions are held in place in the lattice structure. That's all for now. Like, subscribe and press the bell icon so that you can view my latest videos. See you later.